Welcome to Unit 5A, Quadratic Functions. This is the lesson on skill number 34. I can solve quadratic functions by graphing or factoring and determine a quadratic function from its roots. We will start our notes on page 05-09, titling it Solving Quadratic Equations. A term is a piece of an overall expression. So down here we've got two expressions, and in our expression our terms are, for example, 3y squared, 2y, or 5, and in the lower one we've got the terms 4r to the third, r squared, negative 21r, and 3. Next up we have the variable. We're very familiar with the variable. In our first equation our variable is y, and our second equation our variable is r. Next up we have coefficients. Coefficients are the number in front of the variable. So we've got a coefficient of 3. Here we have a coefficient of 2. Here we have a coefficient of 4, 1, and negative 21. It's debatable whether 3 could be considered a coefficient. I'm leaning more towards referring to it only as a constant. The subtlety of this is not important to today's lesson, but alright. Last piece of page 5-9 is factors. And factors are integers that divide evenly into a number. So for example, the number 35, we have 1 times 35 equals 35, and 5 times 7 equals 35. So our four integers are 1, 35, 5, and 7. Our four factors. And they are all integers. Finally, the factors of 24, 1, 24, 2 and 12, 3 and 8, 4 and 6. And as you can see, I like to list the factors as pairs. Starting on page 05-10, something that we can do is we can find the zeros by using a graph or table. I'm not particularly fond of these methods because they're both prone to pitfalls, but we need to know how to do it. So, for making a table, the first step is to write out a table and then fill out the table. Step 3 is locate the zeros. So we find zeros at those two locations. And step 4 is to identify these values as your zeros. As you can see, a problem arises if perhaps you made the table too small. If you made your table so that it didn't quite capture the zeros, then you may not know where the zeros are. So that's why I'm not too partial of using a table. Another method is to find the zeros using a graph. So if you wanted to solve when is x squared minus 25 equal to 0, we could graph the equation x squared minus 25 equals y. And for the familiar grapher, we know that this is a parabola which has shifted down 25 units. However, where exactly does our graph cross the axis? We've got out 1, up 1, out 1, up 3, out 1, up 5. It's kind of hard to tell unless we drew a really clean, clear graph. So that's one of the downfalls of using this method. So we combat those methods by developing a way to do it algebraically. Doing it algebraically means solving by factoring. And we're going to be spending several days developing different factoring techniques. Today, or the first method of factoring that I will teach you is called factoring with the box method. So, on page 05-11, factoring with a factor box or cross. Factor box and cross. This is my preferred method because it does a good job at catching all possible scenarios. I don't want to say it catches all the scenarios because I know it doesn't, but it catches a lot of the possible rational scenarios. It's a several step process, so I'm going to walk you through it with an example. What we have here is an example. Find the zeros of x squared plus 2x minus 8. Step 1 says write the equation to solve. So we have x squared plus 2x minus 8 equals 0. And what we're trying to do is solve that equation. Step 2, we draw a factor box. And the way that I draw a factor box is like this. And in this box I put ax squared. So for us that is 1x squared. In the lower right hand box I put the value c. And see, it's drawn over here, the value c. And for us that's negative 8. At this point I set the factor box off to the side and I create the factor square. So, sorry, the factor cross. So in the factor cross, what I do is I take acx squared and put it in the top. So in our case, a is 1, c is negative 8. So acx squared is negative 8x squared. And then in the bottom, I put bx. And in our case, bx is 2x. We put 2x in there. The next step requires us to find factors of AC. So factors of AC, which in our case is negative 8. So I've listed out the various factors of negative 8. And sometimes you don't need to list all of them to get to the next step, but step 4 and 5 can be done in the head sometimes. I know many students who actually skip steps 4 and 5 and just go straight to step 6, but until you're comfortable with it, what you're going to do is you're going to pick which factor pair, which of these factor pairs add up to our b. So our b was 2. So which of these adds up to 2? And we'll find that the last one, negative 2, 4, the last one adds up to 2. What this means is we can put negative 2x and 4x in the factor cross. And in truth, you don't even have to put them in the factor cross because on the next page you see that negative 2x and 4x go into those two spots of the box. So this is page 5-12. 5-12. And we start with step number 6, which says place factor pair into the box. The next step is to find the greatest common factor of each column and row. So, what is the greatest common factor of x squared and 4x? The only common factor is actually x. So that goes right there. Then we find the greatest common factor of negative 2x and negative 8, and that would be negative 2. So that goes right there. At this point, you could find the greatest common factor of the the rows, or you could say x times what is x squared, x times x, and x times 4 is 4x. Negative 2 times 4 is negative 8. I'll erase this so you can kind of see where those pieces are coming together. And we'll discuss this more in class and practice it. At this point, we use the greatest common rows and factors columns to write the factored form. So what we have is x minus 2 times x plus 4 times x plus 4. X minus 2 times x plus 4. At this point, we have factored our original equation, and we can set that factored equation equal to 0. From here, it's a matter of using the zero product property to solve. If you have this problem that you're trying to solve, we can say either x minus 2 equals 0 or x plus 4 equals 0. X plus 4 equals 0. This gives us two possible answers. The zeros of the equation are x equals 2 or x equals negative 4. From here, you of course check your work and celebrate a job well done. One possible way to check your work is to plug the values in. F of 2 and f of negative 4, we find both of them equal 0. Check, check. Alright, so that's factoring using the box and cross method. I will go over the box and cross method more in class, and we'll practice it together, because it takes a little while to get the hang of. It's tracking a lot of numbers. Because factoring is a multi-day lesson, the next page involves the next lesson. So if you want to pause here before moving to the next page and get questions answered tomorrow in class, that is fine. However, for those who wish to continue, page 05-14. Factoring special binomials and trinomials. So, a binomial is a quadratic expression with two pieces. These are all examples of binomials. Another x squared minus 4. That is a binomial. Trinomials have three pieces. 1, 2, 3. 1, 2, 3. There are special binomials and special trinomials. I think the easiest way to identify special binomials is by asking yourself, is the last piece a perfect square? 9 is a perfect square, 25 is a perfect square. Then the next thing you ask is, are you subtracting it or are you adding it? If you are subtracting it, as is the case in x squared minus 9, it is a difference of two squares. Difference of two squares. What we have is a squared minus b squared is equal to a plus b times a minus b. So you can say x squared minus 9 is x squared minus 3 squared, or x minus 3 times x plus 3. That is the difference of two squares. It only works for differences. There is no sum of two squares, meaning we cannot use this method to solve x squared plus 25. From this point, if we wanted to solve that for equals 0, we would use the zero product property. Here's an example of x squared minus 25, and then a more complex example with 4x squared minus 16. Notice 4x squared is the same as the quantity of 2x raised to the second power. And the quantity of 16 is 4 squared. So we get 2x minus 4, 2x plus 4, 2x minus 4, 2x plus 4. That is the difference of two squares. There is also perfect square trinomials, and these are harder to recognize, but I've written down the two perfect square trinomials, and on the next page we will give examples of these two. Alright. Page 05-15, Examples of Perfect Square Trinomials. So this is your most basic perfect square trinomial, and I thought of this as x squared. You have the quantity x, and then 25 I noticed was a perfect square, so I wrote 25 as 5 squared. From there, it's a matter of what is your middle term. And it looks like it has the x, 5, 2. So if we go back, it should be minus 2ab, minus 2ab, a being x and b being 5, minus 2ab. Because it's of that form, we are able to write it as a perfect square of x minus 5. If we look back at our perfect square trinomial, we can write it as x minus 5. X squared minus 2ab, or 2 times 5 times x, plus 5 squared, x minus 5. The following three examples are very similar in the way that they're thought about. Solving these problems take a little bit of pattern recognition. If you notice, all of them have nice clean square numbers at the end. They also all have nice clean square numbers at the beginning. And finally, if you take a look, they also all have even numbers in the middle. And I don't want to say that even numbers are important for the middle, because you can do it with odd numbers, but if it is an odd number, then your last piece would probably wind up being a fraction. The last piece of this skill is being able to write a function in standard form when you are given two zeros. And most everybody gets this pretty quickly. If you have a 0 of 3 and negative 2, then you're just going to write x minus 3 times x minus negative 2. At that point, you go about simplifying it and then simplifying it down into standard form. So if I said write a function in standard form when you're given the zeros of negative 7 and 6, we would say x minus negative 7 times x minus 6, which gives us x plus 7 times x minus 6, which is x squared minus 6x plus 7x minus 42, or very simply x squared plus x minus 42. There we go. Standard form. ax squared plus bx plus c. Okay, that concludes skill number 34. So for the skill net test for number 34, we will need to know how to factor in a variety of ways. There's the box cross method, and then there is special binomials. Special binomials, that would be the difference of squares. And then there's special trinomials. So we need to know how to do those types of factoring, and then also if we're given two zeros, just like the very last problem we did, find standard form. All right, thank you.